Hello all, here we are with one more example on equivalent static method. The procedure for equivalent static method is same, wherein based on the various criteria you will be picking up the z value, I value, R value using the formula for design seismic coefficient AH, that is zi by 2r into sa by g. We will calculate AH, then multiply that AH with the W, you get the base shear. The procedure is same and all the data is available in the code book. The formulas are also available in the codebook. Only change that can be expected in these examples here is the calculation of the dead load or calculation of the total weight of the building. So here we have another different type of a numerical wherein they have given us how to calculate the dead load. Okay, so a 4-storied RCC special moment resting frame. It's a RCC special moment resting frame. RCC tells me to be used for calculating the natural period Tn, and special moment resting frame tells me R is equal to 5. Conforming to the ductile detailing provision of a residential building has two equal spans of 5 meters each. So this is 5, this is 5, this is also 5, this is also 5. 5 meters across section in both x and y direction as shown in the figure. The height of each story is 3.5. It is a 4-story and height of each story is 3.5. So total height would be 3.5 into 4, that is 7 into 2, 14 meters. Evaluate the base shear and determine the lateral force distribution in each of the floors. Take the live load as 3.5 kilonewton per meter square. The column size. Now here in this particular example, they're giving us the column size and the beam size along with the slabs. The column size is 250 mm by 450 mm. The beams are 250 by 400 and the slab is 100 mm thick. So this is of importance because I look at the dead weight. Consider 250 mm thick brick masonry wall along x direction. So in this direction, these walls are 250 mm thick brick masonry, and along y direction, it is 150 mm thick y direction wall. The soil type is hard rock and the location is Delhi. To get the Z value, importance factor I equal to 1, you will take it as 1.2 according to the new code. Neglect the influence of the stiffness. Okay, so now more important is for us calculating the dead weight. So self weight of the masonry wall we'll calculate first in x direction. X is this direction. Okay, so what is the thickness of the x direction wall? 250 mm. So 0.25 into 5 into 3.1 into 20. 20 is nothing but the density. Such how many walls? 1, 2, 3, 4, 5, 6. Such 6 walls are there. So I'm calculating the self weight of the masonry wall, wherein I'm trying to get it in terms of for the length, breadth, and height, and then I'll multiply it with the density and its number of walls. So 0.25 into 5 is this center to center distance, 3.1 because 3.5 is your total height of the story, and you have the beams of thickness 250 by 400, depth is 400, so 0.4 has to be deducted from 3.5, that makes it 3.1. okay, so 0.25 into 5 into 3.1 into 20 density, such 1 2 3 4 5 6 6 walls are there. Similarly, y direction, in y direction, that is in vertical direction also, it is only thickness changes. 0.15 into 5 into 3.1 is the height into 20 y.1, because I just make a note of it. Date draw. It is notate draw. Okay. .5 minus 0.4. Okay. This is nothing but coming from the beams. Fine. So this is that 3.1. Both the heights after deducting the depth of the beam, and number of walls is 6. 1 2 3 4 5 6. Number of walls is again 6 in each of the case. So this is self weight of the masonry wall. Then height. He's here giving us how is the height of the wall considered. Unit weight of masonry is 20. Then self weight of the columns. Now for columns also I'll have length into breadth into height into its density into number of columns. What is the column size given here? It is 250 by 450. So 0.25 into 0.45 into total height is 3.5 into 25 is the density. Such 9 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 columns shall get the self weight of the columns. Coming to self weight of the beam size is 250 by 400. So the beams 0.25 into 0.4 into 5, that is the length the beam, into 25 density into such how many beams? 6 horizontal, 6 vertical, 12 beams makes it 150 kilonewton. Self weight of the slab, it is 100 thick, so 0.1 into this is 10, this is 10 directly. Slab is going to be same. 0.1 into 10 by 10 into 25, 250. Unit weight of RCC is considered as 25. That is given. So now total self weight of the floor. Okay, what is going to be the total self weight of the floor? I have the weight of the masonry wall in x direction. I have weight of the masonry in y direction. Then I have weight of the columns, weight of the beams, and weight of the slab. That these all together come on the floor. This is of one floor. If I say into 3 or 2, whatever, based on our requirement. Total live load on the floor. Now live load they have given us 3.5 kilonewton per meter square. So 3.5 into 10 into 10, that is 350 kilonewton per meter square. This is the live load. Okay. Next we have seismic weight of is I have to consider the dead load plus 50% of the live load. From the code book I know that I have to consider 50% for 3.52. So dead load plus this, that is 1407.6 kilonewton. Seismic weight of the roof, only the roof. When I'm talking of the roof, I will consider only water data and get back to the previous calculation. Okay, here when we are dealing with the roof, I will consider only the beams and 50% of the columns and the slab. I will not be considering the other details. Okay, so we know that, go back here. I have 50% of your columns and beams plus 150 plus 250. Okay, so that makes the total seismic weight on the roof, and then total weight of the structure is 3 times of the floors plus 1 time of the roof. Okay, now if you still have doubt with this, 465, 279 and 88.6. Okay, you know these are coming from your beams, columns and the roof. We have seen in the previous calculation. 50% of 465, 279 and 88. Sorry, I hadn't shared the slide. So 50% of 465, 279 and 88. Coming from your previous slide, that is here. Yeah. So 50% of the walls in X and Y direction and 50% of columns. So 465, 279 and 88 are coming from for the roof. Basically, I will be considering only walls and columns 50% and rest all I will add them as they are. Okay. So here it is. 50% of that plus the beam and total of the beams and total of the slab. Multiply and get the final answer. Then using the natural period equation, get the value of Tn. For the equivalent static method table for hard soil, 1 by Tn, you get the value of SA by G. Substitute and get the horizontal seismic coefficient. Multiply it by the total weight that is calculated over here. You will get the base shear. Once you get the base shear, same table, weights, various heights, Wi into Hi square, Hi square divided by summation of that and Q. Okay, this is one kind of different numerical wherein you have to solve or get the dead weight from the dimensions of the given section. And when we are considering for the roof, we will take only 50% of x and y direction walls and the columns. Rest all we will take full loads to get the roof dead weight. Okay, so this is for today. Go through the example and try to solve it.